All right, so today in class you saw we looked at this formula sheet and we basically kind of covered these guys up here, all these and all those. We even went down here and talked about these formulas and these, which we'll use a little bit, but not as much as the ones in the top row. So here we go with some problems. We filled this out in class, but it's just based on the formula sheet. So let's go down here to example number 1. Now, of course, skip ahead to where we left off in class if you were there. This is just for people who weren't there. And so we also did these in class with drawing a picture, but we're going to do this with simply using identities, right? And a little bit of a picture. So that's how sometimes you're technically supposed to do it. So the picture is, you know, a little bit cheating or whatever. But anyway. All right, so the secant is -3/2. So -3/2. So that means that the cosine is -2/3, the reciprocal. All right, and let's figure out where we are. So the secant goes with the cosine, the reciprocal, and so the cosine is negative. So already I know I'm not here or here. And then it says the tangent's greater than 0. Well, that must mean that I am here, okay, because that t means tangent's positive. All right, so I can kind of fill some stuff out here. The tangent's positive, which means the cotangent's positive. The sine is going to be negative, and so is the cosecant. So we're only going to use identities. We're not going to draw a triangle picture. Okay, so once I know the cosine, why don't I go ahead and use this guy right here? If I know the cosine, I can figure out the sine using my Pythagorean identity. All right, so I got sine squared x plus, I know the cosine is -2/3, so cosine squared, so -2/3 squared equals 1. So I fill that in and then we work it out. So sine squared, this would be 1 take away 4/9, because if I square -2/3, I get 4/9. So 1 minus 4/9 is 5/9. And let's do the square root. So the sine is plus or minus the square root of 5. I do not know, but the square root of 9 is 3. So this is the reason we had to decide where we were, because I can have plus or minus. Well, I know that the sine is negative, so I'm going to say -5/3. And so that means the secant is 3/5, which you can rationalize and stuff too. Tangent. So for tangent, all I had to do is take my sine over my cosine. That's my tangent. So I will take -5/3 and put it over -2/3. And so when I do that, I get -5/3 times 3/2, both negative. 3's cancel, so I get radical 5/2. And then my cotangent, just flip that over, 2/5. Yes, I am. I sound like a herd of buffaloes. All right, so let's look at this problem here. Cotangent and sine, I'm given those and they're both positive. So once I know cotangent and sine, let's see, cotangent 2/5 radical 5, sine radical 5/3. So I know a lot. I know that I would have 3/radical 5 for the cosecant. For my tangent, I would have 5/5/2. All right, so I just need the cosine and the secant. So I got a couple things I could do. I could use my sine squared plus cosine squared equals 1. I could do that again and find cosine that way. Or I could know that tangent is sine over cosine. So why don't we just go ahead and do that. Let's figure out where we are. Sine is positive, so I'm here or here. And it says tangent's positive as well, so I know that I am here. All right, so all I really have to do is this. Let's see, the tangent, so tangent 5/5/2 is equal to the sine over the cosine. So radical 5/3 over the cosine. So let me multiply that cosine over here. And then I'm going to just multiply by the reciprocal. So if I multiply both sides by 2/5 radical 5, you know, that cancels everything here. And so I get cosine x. And let's see what happens here. The radical 5's go away. I get 2/15. So my cosine is 2/15, which means my secant is 15/2. You guys all done? Good. All right, so let's look at this example here. So tangent is -8. So that means my tangent's negative. So it's one of these two places. And it says sine is greater than 0. So I'm going to be here, second quadrant. So sine is greater than 0. That means plus is there. Tangent's -8. So it means cotangent is -1/8. All right. And let's see. What can we use? So I don't know sine or cosine, but I do know tangent. So let's go back and look at our list. So I could, this one's not going to do me any good right here because that's tangent, cotangent, I already have that. If I was going to use this, I would have to know one of these to be able to, for it to help me. So we're going to use this guy right here. Tangent squared plus 1 equals secant squared. So tangent squared plus 1 equals secant squared. Now I'm using x here, and I realize there were thetas in the problem, but same difference really. So right here I got -8, I'm squaring it, plus 1 equals secant squared. So that means I have 64 plus 1, so 65 secant squared. And so that means a secant is the square root of 65. Which means my cosine is 1 over the square root of 65. Okay, and my cosine, I should have said plus or minus, because actually we forgot to say right here, sine's positive, but cosine's negative over here. So these are both negative. Okay, so now I got a couple different routes. Why don't I do this? Sine squared plus cosine squared equals 1. Or I could go do what I did up here earlier, but I like this better. So if I square the cosine, if I square this, I get 1 over 65. And then over here, I still got sine squared. So I got sine squared. What's 1 minus 1 over 65? So 1 would be 65 over 65. Well, 65 over 65 minus 1 over 65 would be 64 over 65. So my sine is plus or minus, the square root of that would be 8 over radical 65. All right, and so it's positive. So I get 8 over radical 65. Of course, you could rationalize that. And here I get radical 65 over 8. Okay, so next one for you to try. We'll just do this real quick. Cotangent's -3, which means my tangent is -1/3. Cosine is less than 0. All right, so cotangent, tangent's negative, so it's not here. Cosine's less than 0, so it's not there, so here we are. All right, so cotangent and tangent. Let's look back at our formulas. So why don't we go ahead and use this guy right here. Cotangent squared plus 1 equals cosecant squared. So cotangent squared would be 9 plus 1 equals cosecant squared. All right. This guy right here, cotangent squared plus 1 equals cosecant squared. Okay, so cosecant squared is 10, and so my cosecant is plus or minus radical 10. All right, so cosecant goes with sine, and sine is positive here. So sine is positive, that's positive, so cosecant is radical 10, and then sine is 1 over radical 10. All right, and then, I don't know, sine squared plus cosine squared equals 1. We could do that. So sine squared would be 1/10 plus cosine squared equals 1. So 1 minus 1/10 would be 9/10. So the square root of that, the cosine, would be 3 over radical 10 plus or minus. And I know that cosine is less than 0 here, because I'm over this way, so these are both negative, and so 3 over radical 10, and this one's radical 10 over 3. Okay, so once you get a couple of them, it's really pretty easy. All right, so now to the main part of what you have to watch here. So when we look at these problems here, there's many paths that you can follow. So this is the part where, like, we stopped off in class. This is where we're starting now. So remember that, you could do it one way and it would be perfectly right. I could do it another way, perfectly right, but it's just there are different choices, like whatever we see. All right, so when I look at this problem here, I see cosecant and secant. So cosecant and secant mean if it was cotangent and tangent, I'd be like, oh, they cancel out. But these ones don't. So what could I do? Let's change them to sines and cosines. So cosecant is 1 over sine, and secant is 1 over cosine, minus cotangent. Let's go ahead and change this to cosine over sine. Okay, so changing everything to sines and cosines, I mean, I didn't see anything obvious that I could factor or anything like that, so I changed everything to sines and cosines. Okay, that's all coming from this information right here. Okay, all right, so now let me try and get a common denominator. So my common denominator would be sine and cosine together. So if I'm going to do that, that means I have to give a cosine to this guy. All right, so let's see what we got. So I have one big fraction with sine and cosine at the bottom. And this one's just 1 minus and then cosine squared. 1 minus cosine squared. So sine squared plus cosine squared equals 1. 1 minus, oops, what was it? Cosine, crap. I think it's 1 minus cosine, okay. 1 minus cosine squared is going to be equal to sine squared. So let's make that replacement. So the top can turn into sine squared, and the bottom is still sine and cosine. And now I can do something. Cancel, cancel. So I end up with sine over cosine. Well, sine over cosine. You could leave it like that kind of, but basically you can say that it's tangent. And there you go. So that mess right there is equal to tangent. All right, example 5. I immediately think of some factoring I can do. Remember your algebra skills. You have a difference of 2 squares here. So I got secant plus 1 and secant of x minus 1, which then secant of x minus 1, these cancel. Okay, so one of the hard parts too is to know, like, when am I done? And so we're going to also get into things where you know, kind of like you did today in class where you have the identities. The identities tell you like when you're finished, and so those are a little bit easier. But, you know, some of these things, you know, when you're like factor and cancel, you're like, okay, I'm done. I feel done. So that's it. All right. So here, these things, this is one of those, I forget what they're called. These ones right here, these cofunction identities. All right, but I do notice that it's backwards. So let's take a look. So the identity says that sine of pi over 2 minus x is equal to cosine. All right. And we got one other identity we're going to be using here is this guy right here. Sine of negative x, I'm going to say, is equal to negative sine x. So the other one I'm going to use is sine of negative x is equal to negative sine x. All right, so putting those two things together. So first of all, look at this. This right here. Let's turn it around. This is the sine of I'm going to pull out a negative and write it as pi over 2 minus x. Okay, so all I did basically is I switched the order and brought a negative out. So I factored out a negative. So if I put that negative back through, it would turn exactly back into this problem right here, right? So, hang on a second. So now I'm going to use this identity right here. When I have a negative of something that I'm doing the sine of, I can basically pull that negative out front because it's an odd function. So I'm going to pull this negative out front. So I have negative sine pi over 2 minus x. Okay, so all of this right here has now changed into this. And I'm going to go back and write the rest of it. So over here, let's see, I got sine squared cosine x. All right, so now I'm going to use what I wrote in red up here as a replacement. This is replaceable by cosine x. So I got sine squared cosine x minus cosine x. And now I look, I look at this and I say to myself, oh, look at these two cosines right here. I can factor. So let me take out a cosine, and then I get sine squared minus 1. Sine squared minus 1. So sine squared, if I bring the 1 over here, sine squared minus 1 is equal to, put the cosine, negative cosine squared. All right, so you know how to like transform that all around. So negative cosine squared. So this is replaceable with negative cosine squared. So cosine squared and cosine make cosine to the third. So I get negative cosine to the third. And so that would be preferable to all of this mess up here. Okay. All right, so example 7. Definitely want to have two fractions. Usually the thing to do is get a common denominator and put them together. So we'll do that. So that means that I'm going to give a 1 minus sine to this guy. And 1 minus sine. And that means I'm going to be giving a cosine over here. Right, to get my common denominator going. So when I write it, I got 1 minus sine times cosine is my common denominator. So if I give a cosine up here, that's kind of easy. I get sine and cosine squared. And you write it either way. Over here, though, I have minus, and I got to multiply these together. So I'm going to multiply that together over here. 1 times 1 is 1. 1 times negative sine is negative sine. Positive in the middle. And then on the end, minus sine squared. All right, these cancel, so it's 1 minus sine squared. So be careful. We got 1 minus sine squared behind this negative sign, so that it changes, you know, like we're going to have to like give the negative to each part. Okay, so let's see what we got. So I got sine x cosine squared. Now, I think I'm going to make a change here. If I write this out like that, nothing much is going to happen. But wait a minute, I think I notice 1 minus sine squared. So 1 minus sine squared, if I look right here, 1 minus sine squared is equal to cosine squared. That's going to do me a little bit, have a little more use for me. So if I can write 1 minus sine squared as cosine squared, then I have this on the bottom. Now look at that. See why I wanted that? Because the cosine squares are in common, so I'm going to factor them out. So then I have sine minus 1. And it takes a while to get savvy at these. I mean, like, sometimes you're stuck and you're like, what do I do? And you don't notice something. So, you know, just takes a while. All right, so let's take a look. I'll look right here. These pieces are the exact same thing except they're backwards. So, excuse me. So I can cancel those out, but put a negative 1 in their place. Just like if you have x minus 2 over 2 minus x, they're the same thing. It's like you do this. A negative 1 and then 2 minus x, and then you cancel them. So if you just know that little trick, that's a little easier. All right, so look what we got. We got negative cosine squared over cosine. So one of these cosines cancel, so my final answer is just negative cosine. And so all of this mess is just this. All right, so these are our last two. All right, number 8, rewrite this as an expression that does not involve a fraction. Okay, well, la-di-da. Let's see. So, I don't know. I don't really quite know what to do with this. I could change everything to sines and cosines. Secant and tangent do have this little thing right here. So I can multiply by the conjugate, like I can multiply by secant plus tangent, or secant minus tangent. I think I like the idea of changing things to sines and cosines first. I mean, I'd rather do that. All right, so let's see what we got. So we got 4. Secant is 1 over cosine. Tangent is sine over cosine. Oh, so I'm liking my idea right off the bat. I got a common denominator. So this changes to 4 over, this is 1 plus sine over cosine. Okay, so if I flip that up, flip the bottom up, I basically have 4 cosine, and the bottom is just 1 plus sine. All right, well, I am stuck, I guess, doing this. When I see 1 plus sine, so we're about to do a similar thing as down here. If I see 1 plus sine, if I can get going, if I can get this to be 1 minus sine squared, then I can use my Pythagorean identity right here. Okay, so to get this to be 1 minus sine squared, I'm going to multiply by 1 minus sine on the bottom, and then I have to do it on the top too. Oops. But on the top, I'm not really going to multiply it out. I'm just going to like leave it sitting there. Okay, all right, so the top I got 4 cosine and then 1 minus sine, just because I'm not really sure if I need it multiplied on the top. On the bottom though, the whole reason I wrote that, because when I multiply this together, this is what it makes. All right, and then if I look back, 1 minus sine squared is just cosine squared. So now I can change this right here to cosine squared. Now I can see some cancellation. So that means I can cancel this, oh my God, cancel this cosine with one of these. So let's see what we got left. We got 4, 1 minus sine. And the bottom is just a cosine. Okay, so let's do multiply out the top. I got 4 minus 4 sine over cosine. So it said it didn't want a fraction, so I'm going to change this into 2 parts. 4 over cosine minus 4 sine over cosine. Now I'm just saying sine over cosine, but it's really sine x over cosine x. I'm just kind of abbreviating it. All right, so 4 over cosine. So remember, when a cosine's on the bottom, that's really just a secant. So that's 4 secant minus sine over cosine is tangent, so 4 tangent. And there we go. So it doesn't have a fraction, but all right. So last one, number 9. So we were going to multiply this by the conjugate, 1 plus sine and 1 plus sine. All right, so when we do that, the bottom immediately becomes 1 minus sine squared. And the top, I got cosecant and 1 plus sine. Now earlier we didn't multiply this out like in this problem up here because I was like, oh, I don't really see a good purpose. But cosecant and sine are reciprocals of each other. So if I multiply this out, that's going to be cosecant, and that's going to turn into a 1. So I think I will do it. So cosecant times 1 is cosecant. And cosecant times sine, they're reciprocals of each other. So cosecant is 1 over sine times sine makes 1. And at the bottom, 1 minus sine squared. So 1 minus sine squared is cosine squared. So there's my cosine squared. And so now I have 2 items on top and then 1 thing on the bottom. So I can separate them. I just seen something that's not a fraction. So I got cosecant over cosine squared plus 1 over cosine squared. All right, so remember, when cosine's on the bottom, it can come up and become a secant. So that's what I'm going to do. This is going to be cosecant times secant squared plus this will be secant squared. And that's it. I mean, I've met the requirement. It's not a fraction. I mean, I guess I see now that I could take a secant squared out, but if I did that, I'd have cosecant plus 1, so that doesn't really help me with anything. So frankly, it's good to notice, but it's also not needed. Okay. All right, so remember tonight you are doing these 4 problems, and unless I say differently in class today, but that's it. Bye-bye.